Alrighty, I think we will go ahead and get started. Good afternoon, everyone. Thank you so much for joining us today for our webinar titled Is Recycling Working? This is the second webinar in our three-part series called Tackling Plastic Pollution. The chat and Q&A features are available during the webinar today for discussion and questions. We will have time at the end of the webinar for a brief Q&A period, so please feel free to put your questions into the Q&A feature so we can see them. To start off, I would like to introduce our wonderful speakers today. They are GBF's plastic pollution summer students. They are university students at different stages in their degrees from various universities all across Canada. This allows them to bring unique skills and perspectives to the different projects that GBF is working on this summer. I'll start off by introducing Carrie. She is a third-year biology student at Queen's University and is focusing on animal physiology and ecological systems. Next is Emma. She's a third-year Dalhousie University student studying environmental sustainability and international development with a minor in geography. Next is Sophie, who is a second-year biology student at the University of Victoria. And last but not least is Bronwyn, an environmental sustainability and environmental technology student with a specialization in ecosystem management at Lakehead University. And before I turn it over to our wonderful students, I just want to talk a little bit about the organization. So we are Georgian Bay Forever. We are a charity dedicated to scientific research and public education on Georgian Bay's aquatic ecosystems. Our mission is to protect, enhance, and restore the aquatic ecosystems of Georgian Bay by funding accredited research on water levels, water quality, and ecosystems. And now I will turn it over to Sophie to start off the webinar. Enjoy, everyone.
Thanks, Nicole, and welcome to our second webinar in our plastic pollution webinar series. The first webinar, Wearing Plastic, which focuses on the textile industry and its impacts on the environment, can now be found on YouTube. Today's webinar, Is Recycling Working?, will focus all about recycling. And make sure to sign up for our final webinar, Plastic Waters, on August 26th at 12 p.m., which will dive into the impacts of plastic products once they reach our open environment, specifically waterways and how that affects aquatic life. Today, we will be discussing the history and importance of plastic and its effect on the environment. Then we are going to dive into the paths of disposal of plastic, focusing on recycling and some different projects Georgian Bay Forever is undertaking to reduce plastic pollution, along with what you can do in order to maximize the effectiveness of recycling and reduce your own plastic consumption. First, we're going to look into the history of plastic, beginning in 1907 when Leo Bocklin invented the world's first fully synthetic plastic, meaning it contained no naturally occurring molecules. World War I and World War II led to leaps in chemistry, causing an explosion of new forms of plastic, including polyethylene, polystyrene, and nylon plastic. Mass production of plastic also began due to it being easy and cheap to produce and being a more efficient replacement for a lot of products. As a result, plastic production in the United States increased by 300% during World War II. But as plastic became more versatile, the growing issue of plastic pollution and overconsumption of plastic arose. In the 1960s to 1980s, awareness of the plastic issue increased and recycling programs were implemented to try and reduce the growing problem. Today, plastic pollution remains to be a huge issue we face. Humans now produce about 300 million tons of plastic waste annually. That is almost equivalent to the weight of the entire human population. In addition, in the last 10 years, we have produced more plastic than during the whole of the past 100 years. And it is estimated by National Geographic that by 2040, the amount of plastic waste in the ocean will triple, as every year about 8 million tons of plastic waste enters the oceans. That is the equivalent of setting 5 garbage bags full of trash on every foot of coastline around the world. The image to the right is from a 1950s magazine and is entitled Throwaway Living. The idea of throwaway living was created to cut down on household chores by using disposable plastic and paper items you could just throw away instead of washing. Pictured, you see a family embracing this lifestyle with open arms as disposable items fly through the air. It was claimed that every item in the picture would take 40 hours to clean, except that no housewife needs to bother. Just use it once, then throw it away. This mindset has led to our unsustainable, over-consuming way of living when it comes to plastic. Plastic does, however, have many important uses. In groceries, plastic food packaging allows for longer shelf life using temperature and atmosphere control inside the package. Plastics have the advantage of a high strength to weight ratio, allowing minimal material usage and low cost in packaging design. On average, plastic packaging only accounts for between 1 and 3% of the total product weight. Plastic is also very important when considering water issues, as plastics are a clean way to store and transport large quantities of clean water to places lacking proper drinking water. Plastic is very durable and much lighter than other building and transport materials, which results in significant reduction in fossil fuels when transporting items in plastic. Plastic is also very important to the function of vehicles such as airplanes. For example, the Boeing 787, for instance, has an approximated 20% savings in fuel costs due to heavier building materials being replaced by plastic in recent models. Plastics also capture around half the carbon that is used to produce them, and they are recyclable at different levels, which we will dive into the different SBI codes later in this webinar. Plastics are used in everything, from construction to textiles to toys, cleaning products, and so much more. In the medical field in particular, plastic is a necessity. It is used in a wide range of treatments as prosthetics, IV and saline bags, medical imaging equipment, and so much more. The need for plastic in so many aspects of our lives has driven the annual worldwide plastic market to reach $579.7 billion US dollars.
As we have established that plastic is really important to the function of society, and in fact, between 1950 and 2015, over 8 billion tons of plastic have been produced, and the majority of those have been disposed of through landfills, incineration, and other such practices. I want to draw your attention to the right side of this graph, which shows the amount of plastic that is no longer in use. Currently, 2,500 million tons around 25 million tons, around 30% are still in use. The remaining 70% of plastic has been disposed of and is now lingering in our earth. About 500 million out of the 8,300 million, or 6% of the total production, has been recycled. 700 million, 8% has been incinerated, and the remaining 55%, or 4,600 million tons, has been discarded into landfills and litter. Plastic is among the most energy-intensive materials to produce because of the extreme heat required, along with other chemical refining processes. The production of plastic begins with the distillation of crude oil in an oil refinery. Crude oil is heated to extreme degrees, causing it to fractionate or separate into different layers depending on temperature. Naphtha, one of these specific layers, is a crucial component in the production of plastics. The raw material molecules are broken down into units of hydrogens and carbons. These hydrocarbons undergo a polymerization reaction where individual units are added onto a growing chain, or by adding chains together to create polymers with specific properties. Different mixtures of these groups, or different mixtures of the type of reactions, so either by adding individual units or adding groups together, will lead to different plastic properties. For example, polyethylene is a chain of multiple ethylene groups connecting to each other, which creates a very rigid, tough bond that is hard to break. The newly formed polymers are first in a liquid form called resin or polymelt. This polymelt then undergoes chemical processing to turn it into small plastic particles for easier transport before it is delivered to manufacturers. Once it finds its way to manufacturers, it undergoes a post-modification process where specific chemicals or dyes called additives are added to reach the desired qualities. This can result in further changes in flexibility, durability, and temperature resistance, amongst other traits. The ability for manufacturers to modify their plastic products for specific conditions or applications has led to an astounding increase in the amount and the variety of plastic products being produced. In 2016 alone, the world plastic production totaled around 335 million metric tons, with 50% destined for single-use products. Two of the most widely used single-use products are plastic grocery bags and plastic water bottles. Grocery bags are estimated to be used for an average of 15 minutes before being discarded. So if you can visualize one family buying groceries for a week, they will probably use 2 to 6 bags for their trip. Multiply that by at least 150 people that visit the store in a day, and that's already 300 bags that will be used for a quarter of an hour just to be discarded. Plastic water bottles are equally as bad. They were the top trash collected during Canadian shoreline cleanups in 2019. These are of special concern because they are used for an average of 12 minutes, and they never really go away once they are disposed of. They break into smaller and smaller pieces, and even that can take 450 years. Plastic is also just a fossil fuel in another form, and plastic manufacturing plants can release over 100 concerning chemicals into the air, contributing to air pollution. This pollution contains carcinogens such as benzene, toluene, ethylbenzene, and xylene. In the air, these chemicals can contribute to health problems in nearby communities such as asthma, lung cancer, brain and organ damage, and cardiovascular diseases. And that's not even the peak of it. Scientists are estimating that we are on our way to hit 1.34 gigatons of greenhouse gas emissions by 2030. So to put that in a bit of perspective, it is the equivalent to the emissions released by more than 295 new coal-fired plants in a year. And as I mentioned before, in the production of plastic, it is typically shipped to manufacturers in the form of pellets to ease the cost of transportation. However, sometimes these pellets can make their way into the external environment through improper management. Birds, fish, and other marine animals often mistake these pellets for food and ingest them, resulting in many health problems that can move up the food chain. For this reason, it is important to understand how plastic should be disposed of.
There are 4 main paths to disposal for plastic. These are landfills, litter, incinerators, and recycling. In Canada, only 9% of plastic gets recycled, 86% goes to landfills, 4% to incinerators, and the last 1% is littered. And more specifically, Ontario's plastic recycling rate is 11%. As just discussed, a lot of plastic ends up in landfills, and this can cause an abundance of problems. One of the issues is the process of plastic degrading. When water passes through the plastic, it causes leachate to be created, which then leaches chemicals into the water and ground. In addition, overconsumption of plastic is causing landfills to fill up. Ontario landfills receive over 8 million tons of plastic waste each year, and landfills everywhere are reaching capacity. Ontario's available landfill capacity is expected to be exhausted by the year 2032. The 3 main landfills in the Simcoe County area will all be required to close very soon as they are overflowing. Closure to the Collingwood landfill site is estimated for as soon as 2024, while Nottawasaga is estimated to be closed by 2025, and Oro-Medonte is closed by 2030. There is a proposed idea to continue to expand landfills and build more, but this can take time to approve. So the current plan for when landfills reach capacity is to divert the waste to other landfills and continue to send waste to states like Michigan and New York. Litter finds its way into our environment and eventually into our waterways with the help of rivers, streams, storm drains, and many others. In Canada, the 1% of plastic that is littered every year that I mentioned before is 29,000 tons. Plastic pollution in the Great Lakes is at concentrations equal to and greater than concentrations in the floating islands of plastic waste in the ocean. This is very concerning, especially because 8.5 million Ontarians and many more people surrounding rely on the Great Lakes for clean drinking water. The garbage can also cause harmful effects to animals when they get entangled or ingest them, and the plastics will degrade into microplastics, which can be found in almost every place of the world, including the Arctic, precipitation, beer products, and animals. Macroplastics are the large pieces of plastic that you can see with the human eye. These macroplastics eventually break down into smaller and smaller pieces in the environment called microplastics. There are many reasons as to why plastics break down. The first is sunlight. When exposed to enough sunlight, the UV light causes a chemical reaction in plastic, causing it to degrade into smaller pieces. Similar to how the sun is able to give us a chemical reaction on skin and give us a sunburn. They also break down due to oxidation. Over a long period of time, chemicals in the plastic react with oxygen in the air, causing further breakdown of the plastic. The last way is friction. Plastic littered in the environment is pushed around by wind, waves, and animals, which slowly degrade the plastic every time it rubs up against other objects. Microplastics are smaller than 5 millimeters and rarely visible or noticeable to the human eye. These microplastics are in large abundances in the air, water, sediments, and organisms. Although these microplastics are not visible after they break down, they still have very harmful effects on the environment, ecosystems, and humans. And our next webinar, Plastic Waters, is on August 26th, and we'll dive into the harmful effects of plastic degradation and microplastics in our environments. So make sure to sign up for more information. The first implementation of curbside recycling in Canada began in the 1980s. For a long time in the past, some waste was purchased by recycling companies from the municipalities, but the materials that were contaminated by food scraps or were just not easily recyclable were sold largely overseas to companies in China. In 2016, exports made up 41% of the recycling market in Canada, and since 1992, China has accepted 42% of the world's unwanted plastic. But on January 1st, 2018, China stopped accepting contaminated recycling and imposed strict regulation on what Chinese companies could import. Some types of cheap plastic and mixed paper have been banned, and materials accepted must meet contamination standards of 0.5%. Not only does that mean no greasy pizza boxes, but also coffee-stained paper will no longer be accepted. These new regulations have put a strain on recycling programs everywhere, and not just Canada. Some communities have had to halt their recycling programs, and recycling centers are stuck with multiple tons of waste that is costing them money to store and transport. Residential waste management and recycling services are mandated by the provincial government, but carried out by local municipalities. Municipalities can develop their own waste management and recycling programs, which can include curbside collection, depot drop-off, pay-as-you-throw, or any combination. And municipalities and local governments regulate waste management and recycling through bylaws. They can set limits for the amount of garbage that can be generated by residents, determine fees for waste collection service, and set landfill bans. There are many reasons as to why only 11% of plastic is recycled in Ontario. Many types of plastic are simply unable to be recycled, or it is not cost effective to recycle them. For example, SPI code number 7 is a mix of differing resin levels in the plastic, and therefore the different types of plastic inside are unable to be separated out, and the plastic cannot be recycled. Most plastics cannot be recycled forever. Each time plastic is recycled, the polymer chain grows shorter and shorter, causing its quality to decrease. And the same piece of plastic can only be recycled about 2 to 3 times before its quality is so low that it can't be used again. And for this reason, virgin plastic is usually added to recycled plastic when creating new products to increase the quality and durability of the recycled plastic product. In addition, there are many consumer errors that can mess up entire batches of recycling, causing plastic that could have been recycled to be sent straight to the landfill. So make sure to check your municipality's recycling sorting guide to ensure you recycle properly. And although much of Ontario's recycling is shipped away, there are still various recycling facilities here. These facilities are privately owned businesses and purchase plastic recycling from regional facilities. And using recycled plastic, these facilities are able to create a raw material, which can be used to create recycled plastic for use. Other companies can then purchase the recycled pellets from these facilities to create their products. And you may be thinking, why don't companies use recycled plastic to create their products? And this is simply because virgin plastic is cheaper than recycled plastic.
Now, in the last slide, you saw that certain facilities only accepted certain SPI codes. Now, you may be wondering about the significance of these SPI codes, and they are a resin identification coding system, and they were developed in 1988 by the Society of the Plastics Industry. Contrary to their appearance, these symbols do not determine whether or not a product is recyclable. Instead, they indicate the type of plastic composition, specifically their resin content. So these codes are located inside small triangles, commonly on the bottom of containers. And products that look the same may not be. They can be made out of different plastics because resins are each very different and unique molecules. Some resins mix together and some don't. For those that don't, it's like trying to mix oil and water together. It just won't work. If incompatible resins are mixed, it will result in a low quality, unusable plastic. Different local recycling facilities may only accept certain codes. By knowing this and being able to separate out your recycling, it reduces the sorting required by the facility and is therefore going to reduce plastic waste that ends up in the landfill. So we'll talk first about SPI code number 1, PETE or PET, polyethylene triphthalate. It's a very clear and hard plastic. It's most commonly used in single-use containers. PET plastic actually makes up 96% of all water bottles in the US. It's the most recycled plastic globally, and it's in many post-consumer products like recycled polyester, such as we talked about last webinar. Some studies have shown that PET can leach toxic minerals into the contents of containers in amounts that exceed US safety regulations. And this happens when it's exposed to extreme heats. And this can be as much as leaving hot water bottles in a hot car or putting something into the microwave. SPI code number 2 is high density polyethylene. It's a hard plastic as well, although it's not as clear as PET. It's most commonly used for household products such as detergents and cleaners. Codes 1 and 2 are the most commonly recycled codes. Facilities only have the ability and the technology to recycle these 2 codes. This plastic, like many others, has been researched and it has shown that estrogenic chemicals can leach out of it when it's exposed to heat. These chemicals result in harmful reproductive health effects, and they've been linked to breast cancer, testicular cancer, early puberty, and other malformations of the reproductive tract in men and women, according to the US Environmental Protection Agency. SPI code number 3 is polyvinyl chloride or PVC. It's not as hard as the previous 2 numbers, and it's most commonly used in construction, so stuff like piping and decking. However, it can be found in many everyday items that we use in our lives. It has an average working life of 30 to 50 years, and it's one of the least recycled materials. So less than 1% of PVC is recycled each year, and it's been called a poison plastic. And part of the reason this is because it leaches harmful materials when it's exposed to water. Also, 4 of the most commonly used chemical softeners associated with PVC processes are on the European Chemical Agency's list of substances of very high concern. And so these chemicals are disrupting endocrine system, which is your hormonal system, which is going to cause even more harmful reproductive effects. SPI code number 4 is low density polyethylene, and it's a soft and flexible plastic, so it makes it perfect for the use in stuff like plastic bags. Packaging and container made from LDPE makes up 56% of all waste. 75% of this is coming from residential households and is considered to be a low hazard plastic. SPI code number 5 is polypropylene, and it's most commonly used in lids and medicine bottles. It's considered a fairly safe plastic. However, it is the least recycled plastic. And this is because of the high heat and other processes required in order for it to be recycled properly. SPI code number 6 is polystyrene, recognizably trademarked as styrofoam. It's most commonly used for single-use products like takeout containers or coffee cups. It can also be found in dock foam, in unencapsulated floating dock foam, and it breaks away into the smallest of pieces just by touching it the littlest bit. And this is one of the most common microplastic that we find in our waterways. Because polystyrene has such a low density and it's made out of mostly air, it makes it very hard to recycle this plastic, and it's not cost effective to recycle this plastic either. So it has very low recycling rates as well. Some scientists are reasonably anticipating it to be a human carcinogen, as it also exposes materials when exposed to heat. It has been recommended that this product isn't used for food packaging for these issues. And as mentioned before, there are millions and even probably billions of uses of plastic, and each require different properties and capabilities from the plastic for its designated product. So the plastic that you have in your car is going to be different than the plastic that you have in your t-shirt. And so this is resulting in hundreds of different mixes of plastic and different types of plastic. And it would be too difficult, almost impossible, to be able to categorize all this plastic. So it's put into this category 7, other. And category 7 is ambiguous. It encompasses plastics that are different from 1 to 6 and other mixtures of resins and other plastics. These are rarely recycled because the mixed plastic cannot be separated and recycled conventionally. Many products in this category may contain the chemical BPA, which has been linked to hormonal changes, reproductive problems, asthma, and obesity. If you're interested in how plastic products are affecting human and ecosystem health, please attend our next webinar, Plastic Waters, and we'll go even more in depth in it. As I just mentioned, lots of products are made out of more than one material, and this makes different components hard to differentiate before recycling. We can see there's 2 different cartons on the side of the slide there. One of them is refrigerated and one of them is shelf stable. And you can see the different layers. There's plastic, there's cardboard, there's paper, there's even aluminum in there. And all of these have to be recycled and separated in order for them to be recycled properly. So products need to be designed with their end of life in mind to help ease the intensive processes and difficulties involved in trying to give plastic that second life. And so you can see at the bottom of the slide, sometimes labels like this can be found on products, and you can separate out the various components yourself in order to ensure that your product is being recycled properly.
Recycling is hard to pack into a nice little box to present, as different materials require specific procedures depending on the type of plastic used or the additives found in the product. There are, however, some steps that remain constant throughout recycling. It starts at waste collection and transportation of that waste to recycling facilities. At these facilities, recyclables are sorted into different categories based on the SPI codes that were previously mentioned, and the contaminated materials are removed from them. Materials are then baled, washed to remove labels and other small contaminants, and shredded into fine strands. This is where we re-encounter the initial production process of plastics. The fine strands are melted by heat and pressure, turning it into a resin before it is pelletized and turned into new products like bottles, liquid containers, packaging, and more. Before we get into a specific example of recycling, I want to talk a bit more about the actual process of recycling. So there are 2 main groups. There is mechanical and chemical. Mechanical is the traditional method and involves extruding either pre-consumer polymers, polyester products that were discarded due to manufacturing abnormalities, or polymer waste streams sorted by recycling plants. With proper control over processing conditions, many plastics can undergo several of these cycles without any changes to the structural integrity of the product. However, when we encounter chemical recycling, which encompasses recycling that is used on polymers which can no longer undergo mechanical recycling, it uses chemicals amongst other techniques to break plastics into their core components before reassembling them, as we spoke about earlier. Chemical recycling is also specifically used for plastics that are unusable for any other type of recycling and is instead used for energy recovery processes through pyrolysis. This pyrolysis is a form of decomposition through extreme heat to recover carbon from plastics, which can be made into fuels and other carbon-based products. A specific case of textile recycling is shown here. It follows the skeleton of typical recycling, beginning at collection with clothing drives, donation bins, and special textile pickups. An example of this in Collingwood itself is the textile pickup near the bowling alley on here, Ontario Street. Textiles are sorted between reused and recycled materials. If they are recycled, they are then sorted based on their material composition and the type of fibers used. Polyester-based fabrics are shredded into small pieces, which are then ground by machines and shaped into small pellets, which can be used to produce new polyester fabrics. Cotton-based fabrics are a little tougher. They have to be sorted in terms of color to reduce the need for re-dyeing. The fabric is torn into fibers, which can be combined with other fibers, then cleaned and spun into new textiles. These are often what mattresses, furniture, and car interiors are made from. 12 million tons a year of textile waste dumped into North American landfills, and Canadians only recycle approximately 15% of wearable and 1% of non-wearable textiles. So it's really important to remember that similarly to plastic water bottles, textiles will only be recycled if they make it into one of these types of locations so that they can be transported to proper centers. In light of the issues that can arise with regular recycling, the world has transitioned to different kinds of plastic alternatives. These alternatives include biodegradable, oxo-biodegradable, and compostable plastics. The compostable label generally means that a plastic will break down within a specific time in a commercial composting facility, but that assumes that the plastic gets to the facility, and if it doesn't, all bets are off. There is essentially no guarantee that those items will break down at all. As for biodegradable and oxo-biodegradable plastics, there are no clear standards for how quickly products made from them must break down, under what conditions, and into what components they'll break down into. In fact, a study done by Napper and Thompson out of the University of Plymouth tested a compostable bag, a biodegradable bag, and two types of oxo-biodegradable bags in different environments and tracked how they would deteriorate in 3 years. The study found that none of the bags could be relied upon to show any substantial deterioration over this 3-year period in all of the environments. They also found that the rates of degradation of the plastics in different environments will strongly depend on the local conditions to which they are exposed. In terms of biodegradable plastics, there are two classes. Bioplastics, whose components are derived from renewable raw materials. The molecules of cornstarch and its composition slowly take on water, swell, and eventually fragment. These fragments are what is made into the final product. There are also oxo-biodegradable plastics made from petrochemicals with biodegradable additives that enhance its ability to biodegrade. Unlike petroleum-derived synthetic polymers, biodegradable plastic polymers can be degraded by non-biological and biological processes. The biodegradability of plastic is dependent on the chemical structure of the material, on the physical makeup of the final product, and the conditions of degradation. Under specific conditions, biodegradable plastic waste is turned into compost, which is usually exposed to air, or anaerobically without oxygen where it is buried underground. It can also be recycled and converted into new products via chemical recycling and mechanical recycling. Since degradable and compostable materials are typically not compatible with widely available recycling infrastructure, it is important that you are informed of the appropriate disposal route, in which most circumstances will be disposal to the residential waste stream. And it's not to say that there's no hope for biodegradable plastics. Scientists have found different biotic compounds that have shown promise in the goal to degrade plastic products. Exposure to UV light, thermal heating, and treatment with acidic or basic substances function as decomposition initiators. This results in fragments of polyethylene that are then degraded by the action of specialized proteins produced by mushrooms like the oyster fungi and the split-gill fungi, which are shown on the right, who have shown their ability for treatment of industrial waste. There has also been news of a bacteria that was found to produce a protein system that is able to deconstruct PET, which is a constituent of a lot of plastic products, into its core components. Essentially, that means that this bacterium can utilize the synthetic polymers that are found in the plastic products as a reliable source of carbon and energy for its growth. So whilst this is a really new finding, it provides evidence of a bright future where protein engineering can increase the performance of this protein and hopefully provide a way for how we can move forward with all of the plastic production, plastic pollution that is currently found in our environment. Here are two graphs that show the release of each material when it's being broken down. On the left are regular petroleum-based plastics, which mainly release toxic materials and carbon dioxide. Comparing this to the right side graph, which shows green photosynthetic material, which is the stuff that is used in plants to create energy, and carbon dioxide being the highest released. The amount of CO2 being released from the bioplastics, however, are significantly less than that of regular plastics. So increasing the percentage of bioplastics could be used to drive down CO2 emissions. Bioplastics are produced from plants, which capture atmospheric CO2 as they grow. And if they are composted, the carbonaceous material in the bioplastics are released back into the atmosphere as CO2, which makes the material itself carbon neutral, although the manufacturing still generates a small amount of greenhouse gases.
A linear economy focuses on a take, make, waste model and disposing of materials after one use and minimal recycling and reusing. We are currently living in a linear economy where the value is in selling as many products as possible. A circular economy is what we want to move towards, which focuses on keeping products and materials in use, designing out waste and pollution, and regenerating natural systems. A circular economy designs for durability, reuse, remanufacturing, and keeping products and components circulating in the economy. This is a more detailed diagram of a circular economy. On the left side, represented in green, are the biological materials. These are the materials that can safely re-enter the world once they have gone through one or more use cycles, well, they'll biodegrade over time, returning the embedded nutrients to the environment. On the right side, represented in blue, are the technical materials. These cannot re-enter the environment. These materials, such as metals, plastics, and synthetic chemicals, must continuously cycle through the system so that their value can be captured and recaptured. And within the technical side of the graph, the inner circles are favorable because they require less processing, labor, energy, and virgin material to be of original value again. And reuses within the technical side of the graph can be maintenance and repair to extend the lifespan, reuse and redistribution, refurbish and remanufacture, and recycle by retrieving parts or materials from the product for reuse. And we cannot simply just change one element of the existing system and expect things to be different. We must change all elements to really make an impact. And experts believe that the circular economy has moved beyond proof of concept, and it is now time to mainstream it and bring it to scale. And Ontario has begun taking those steps by planning to make changes to the current Blue Box program and move towards a better system that is way more successful in recycling. This system is called Extended Producer Responsibility, or EPR, and this system has been extremely successful in BC. They now have a 69% recycling rate and the highest in the country. And as discussed before, Ontario's recycling rate is only 11%. And the transition to the enhanced Blue Box program will be staggered from 2023 to 2025. It is combining 253 local programs into a single provincial collection system managed by producers to improve recycling operations across the country. It encourages producers to find efficiencies that will make recycling simpler and easier for residents while also driving innovation, because like Bronwyn mentioned, it is important to think about the recyclability of a product before it is manufactured. The enhanced Blue Box program will make recycling easier for Ontarians by expanding collection to all communities outside the far north by 2026, standardizing what can be recycled across Ontario, accepting common single-use and packaging-like products, collecting single-use items that are distributed or sold to consume food and beverage products, expanding services to more facilities such as apartment buildings, municipal-run or nonprofit long-term care homes and retirement homes, and schools. They will also be expanding collection to more parks, playgrounds, and transit stations, tripling the number of public space recycling bins funded under the current program. EPR transitions the cost of the Blue Box program away from municipal taxpayers by making the producers of products and packaging fully responsible for managing the entire life cycle of their products, and an estimated savings of 156 million annually for municipalities. The first municipalities to transition will be Kenora, London, Toronto, and the town of Hawkesbury. And locally, the town of the Blue Mountains will begin October 1st, 2023. Collingwood and Parry Sound will begin January 1st, 2024. And finally, Township of Georgian Bay on November 19th, 2024. And the Government of Canada also has a plan. Their plan is to have zero waste by 2030. It is in the process of banning harmful single-use plastics where there is evidence that they are found in the environment or often not recycled, and they have readily available alternatives. So things like plastic checkout bags, straws, stir sticks, six-pack rings, cutlery, and foodware made from hard-to-recycle plastics. This plan will protect wildlife and our waters, reduce greenhouse gas emissions, and create jobs. The regulations will be finalized by the end of 2021. PEI has also introduced a Plastic Bag Reduction Act that prohibits businesses from providing single-use plastic bags at checkout. Customers are encouraged to bring their own bag, or businesses can provide alternatives such as paper for a small price or other reusable bags. It came into place in July 2019, and after just 1 year of the ban, there were 15 to 16 million fewer bags in the island's waste system. Nova Scotia has done something similar, and over 35 other countries have taken similar action, including France, the UK, and Bangladesh. However, these are low-hanging fruit to tackle in the fight against plastic pollution. All consumers, businesses, and governments need to shift their focus to reducing the use of single-use plastics, as well as search for sustainable alternatives.
Approximately 10,000 tons of plastic waste enters the Great Lakes per year, according to the Rochester Institute of Technology, and the majority of this plastic is single-use plastics. Georgian Bay Forever has developed a program to reduce plastic waste called Plastic Free Georgian Bay. We have the intent to reduce plastic waste by expanding public knowledge about plastic pollution and demonstrating how everyone can take action in supporting a circular economy. We partner with local businesses to create an action plan to eliminate, reduce, and replace plastics in their businesses. If you are or you know business owners that would be interested in being a part of this program and helping to stop plastic pollution, please email Nicole Diamond at gbf.org. Her email is at the bottom of this slide. Plastic Free Georgian Bay is a part of Diversion 2.0, which is one of the huge projects that we have going on at Georgian Bay Forever. We have installed a variety of collection devices and partnered with townships and marinas to install these. We have gutter bins, sea bins, and trash traps. They actively trap plastic at common sources of pollution, such as storm drains and on the culverts of drains on main streets. Even these sea bins act as stationary surface water vacuums that suck up debris into their internal nets. We'll go more in depth about these collection devices in our next webinar in August. We also do waste characterizations or deep dives. So sea bins collect a variety of macro and microplastics, and the contents of these sea bins can be weighed and characterized. So we GBF members and groups and local volunteers collect data and send it away to be analyzed by the University of Toronto's trash team at the Rockman Lab. If you're interested in being a part of this or want to be a volunteer or know people that would be interested in volunteering, please email Nicole Diamond or visit our website to see updated dates and locations about where we are putting these events on and how you can sign up.
After looking at what Georgian Bay Forever has been doing to reduce plastic, we're going to look at some things you can do to help the plastic pollution problem. One way to make a change in your community is volunteering at shoreline cleanups. You can do your own shoreline cleanup with friends or join one of Georgian Bay Forever's weekly cleanups that we organize and participate in. One cleanup we host weekly is at Harborview Park in Collingwood every Tuesday from 9 to 11 a.m. Shoreline cleanups can make a huge impact, as last year GBF hosted 13 shoreline cleanups with 112 volunteers who picked up 1,369 pounds of garbage in total. Another shoreline cleanup GBF is hosting will be held in Wasaga Beach and is partnered with the Rotary Club. It will be on August 9th and 23rd from 9 a.m. to 11 a.m. at Beach Area 3 next to the Comfort Station. At these cleanups, we use trash tally sheets, which is pictured on the slide in the middle, and used to track the amount and type of waste we are collecting. We have trash tally sheets available, which you can use on your own shoreline cleanup and send in to us when you are finished to add to our data collected. In order to stop plastic from reaching our shorelines in the first place, it is important for us to all work to reduce, reuse, and recycle as much as possible. The easiest way to divert household waste from landfills, litter, and recycling is to reduce our consumption of single-use plastics. It is very important to refuse plastic whenever possible. For example, small changes such as bringing a reusable water bottle around instead of using plastic water bottles, bringing your own reusable bag instead of getting a bag at a store, and using reusable containers at refilleries. The second R, which we all know, is reuse. Whenever possible, reuse plastic. Plastic grocery bags can be reused next time at the store or reused as garbage bags. Hard plastic containers, such as yogurt containers, can be reused to store food in the fridge or freezer. And there are many creative craft ways to reuse plastic, such as reusing plastic bottles for plant pots crafts. By following our Instagram at GBayForever, you'll be able to see our upcoming reused plastic craft videos and more plastic reduction tips. There are many recycling mistakes we make without even realizing. One mistake is leaving food waste in containers. Containers put in the recycling should be as clean as possible, as food residue can contaminate other paper and plastic in the recycling, increasing the cost of processing and causing the contaminated items to be diverted to the landfill that would have otherwise been recycled. In addition, hazardous waste in containers should not be put in the recycling. These are called household hazardous waste and can be identified by the warning symbols shown on the lower diagram to the right. They are found in every home and include batteries, cleaners, paints, motor oils, chemicals, and more. Make sure to dispose of these chemicals properly according to your local waste management guide, as they can also contaminate other recycling items, causing them to be sent to the landfill. Wish cycling is another huge consumer error when recycling. Wish cycling is the act of throwing other materials, such as textiles or garbage, into the plastic recycling in hopes that they're able to be recycled. Make sure to check your local recycling standards to make sure everything you are putting out is able to be recycled. Another common mistake is putting black plastic in the blue bins, typically these black takeout containers. Due to their color, they are unable to be sorted by the recycling machines and cannot be recycled. A better option is to try and reuse those containers. Again, it is very important to check what the recycling standards are in your municipality to maximize the effectiveness of your recycling. These can be found on your area's waste management website. Thank you so much for joining us today. Please know that your support enables our work. We also want to acknowledge our funders for these projects and our partners as well. Thank you again, and if there are any questions, please send them in the Q&A chat.
Wonderful. Thank you all for that great presentation. And thank you all for joining us today. Please, if you have any questions, go ahead and put them into the chat. We do have one question here that students, if one of you want to take a stab at. Curious how recycling centers actually sort the various types of plastic, since some only handle certain types of plastic, the SBI codes, and also wondering about the compostable plastics as well. Does anyone want to answer that?
I can take a go at answering that question. So when plastics are sorted at facilities, they're sorted according to their densities. So you can think about PET plastics are like hard and they're not very flexible compared to styrofoam, which has a lot of air in it. So it's going to be a lot less dense. That's how the sorting works at the facilities. When they're sorted out, the things that are sorted out, I'm not sure if they can be sold to other facilities. commonly they'll just be sent to the landfill with whatever can't be recycled by that facility as well. With compostable products, Canada has a compost program, as you know, with the green boxes, and normally that compost is sent away to farms, gardens, etc. However, the composting system in Canada isn't that great as well. So most of those products get sent to the landfill as well. I hope that answered it a little bit at least.
Wonderful. Yeah, please continue to put any questions you have in the chat, or sorry, in the Q&A section. And here's not really a question, but more of a tip, is when you're at the store, you know, whether you're grocery shopping or at any store where you're buying products that are packaged, is to look at that packaging and see if it's using materials that are recycled, so that post-consumer waste. And usually if the packaging is made of recycled materials, they go out of their way to label it so that you are aware that you're using a product that was made from recycled materials. Here's a question: would it be better to go back to glass containers? So I can go ahead, Gary.
Oh, okay. It's not necessarily going back to glass containers, as you can still kind of use them in your homes. So if you get like pasta sauce or anything, you can reuse those containers for other stuff, but it's more convenient for a lot of manufacturers to just use their plastic component or their plastic products for like keeping things together. So it's more on like our side to encourage manufacturers to use plastic or use either like better types of plastic, so compostable products or biodegradable products, or those like glass containers themselves. But it's not like an our thing, as opposed or more just when you're reusing things that we've already kind of bought from the store.
Great, yeah, and I think Carrie touched on it earlier in the webinar as well, that when it comes to shipping items that are packaged in plastic versus glass, the items packaged in plastic are obviously much lighter and therefore easier to ship and more cost effective to ship versus the glass containers, unfortunately. And here's a question about green box waste. I'm guessing your compostable waste. In Collingwood, does most of that end up going to landfill? If so, why sort it out separately? Does anyone have? I personally don't at this time, and I can definitely dive into it. Whether or not most of the compost in Collingwood is going to landfill or not. I will just say that some municipalities are not able to accept compostable and biodegradable products within their compost facilities, because some of these products require very specific temperatures and conditions to be able to actually be broken down. So unfortunately, in many municipalities, those types of products like compostable forks or biodegradable bags will be taken out of your compost green bin and sent to landfill. Here's another question. Could the longest lasting plastics be used to fill mines formerly used to extract copper, nickel, coal, etc.? That is a great question that I do not know the answer to off the top of my head.
A lot of the time with that, landfills are created in mind, or keeping in mind like different communities that are like around the area. So if you can imagine, like the reason why we don't want things in landfills is because of the leachate that can happen. So if we have, plastic products ending up in the landfills, and those chemicals are going into the grounds, that can make like the ground conditions worse. So a lot of the time with specifically designed landfill sites, they have people that look around the area and see like, is this going to negatively affect our waterways if it can spread out that far? Is this going to negatively affect the rock composition in the area? Will it cause like different kinds of like mudslides and things like that? So it's kind of, if they haven't been designed for that area, if landfills haven't been designed for that area, it's kind of difficult for us to reuse them in that way because of the negative effects that could potentially happen. So it's likely that we could use them, and we could have, you know, different like geologists and things like that to look at the areas and design them or designate them as safe, and we could use them, but with the intent, or like usually we don't have the intent of using them as landfills afterwards. So they're not, the safety protocols aren't really in place for that kind of thing.
Great, thanks, Carrie. Here's another one. With the upcoming changes in the recycling program, do you see Ontario's recycling going down, i.e. being less than 11%? It seems like we are not achieving what we need for recycling packaging and are at the mercy of the producers.
So I think that ties into the advancement of our Blue Box program that Emma talked about and the extender producer responsibility. So we're putting the pressure on the producers now with this extender producer responsibility program, the EPR program, so that they have to control all of the recycling, and they are paying for that instead of our taxpayer money paying for that. So ideally, the recycling rate should go up.
And the producers would start making products that are more easily recyclable, so that they don't have to pay as much for the recycling process itself, is kind of what the point of this program is. So yeah, it would technically go up, hopefully, is what the goal is.
Great, thank you both for that answer. Let me just take a look here. Please continue if anyone else has a question. We have just a couple minutes left. Here is one more question. Why not make products that cannot be recycled and therefore not have to worry about this anymore and save money?
Recycling is a great program, and it's great to have, and it does support that circular economy. The point of the circular economy is that we don't want any products that we produce just to go straight to the landfill and have no use after life. We want to keep them in the economy and keep that circular economy going and keep that as an important part of what we're using in society. So if things aren't recyclable and aren't being reused and don't have like a second end of life plan, it's gonna probably be closer to following the linear economy, which we're trying to distance ourselves from.
Great, thank you.
Sorry.
Oh, go ahead,
the other point of that is we want to make this a sustainable, reusable system. So if we have things that are not recyclable, eventually we will run out of crude oil, which is the main like factor of being, or the main component of being able to make plastic products. So if we run out of that, then gas prices go up, and everything else that we use crude oil for will become like, we won't be able to make it essentially afterwards. So to make things recyclable is to take out the pressure that plastic puts on that oil and gas and all the other products, like the economy for all of those other products, so that we don't like destroy that industry as well. And it also helps create an environment that is like more healthy, because if we have products that can't be recycled, then who knows what kind of chemicals are in there, you know, and what can that affect, or what effect does that have on environments?
Great, thank you both. Well, I don't see any more questions in the chat, and we have reached 1 p.m. I want to again thank you all for joining us today. If you have any further questions, please feel free to email myself at nicole.diamond@gbf.org or our info@gbf.org. Presentation was recorded and will be available for viewing on our YouTube channel. Thanks again for joining us, and we hope to hear from you all and see you at some of our volunteer events. Take care and have a great day. Bye.